Right here, right here we have a function y equals 5. Now, if we were to say that we're looking for the limit of this function y equals 5, in other words, we're looking for the limit of 5 as x approaches a, notice that for those values approaching a, their corresponding y values have nowhere else to go but the same place, 5. And it's the same for those values approaching a from the left. They have nowhere else to go. Their corresponding f of x values have nowhere else to go but the same place, 5. And so that is why we come to the conclusion that the limit of a constant as x approaches any number a is that very same constant. Now that is one of many properties of limits. We call these properties or laws of limits. Another one is that the limit of x as x approaches a is equal to a. And we can tell that one by direct substitution. So for example, the limit of x as x approaches 2 is equal to 2. Now, let's look at another law or another property of limits. Let's look at one that says the limit of, let's say, x to the n as x approaches n will be equal to n to the n. So, for example, let's say that we have the limit of x squared as x approaches 2. That would give us 2 squared, which is equal to 4. So the limit of x to a power as x approaches any number n, all we do is direct substitution. Just plug this number in there, saying that x is equal to that number. Let's look at another property. The limit of the sum of two functions, f of x and g of x, would, as x approaches a, would be equal to the limit of f of x as x approaches a plus the limit of g of x as x approaches a. In other words, we're saying that the limit of the sum is the sum of the limits. For example, let's say we're looking at the limit of x squared plus x as x approaches 2. Based on the property that we looked at a while ago, that would be equal to the limit of x squared as x approaches 2 plus the limit of x as x approaches 2, which, as we learned before, would be 4 plus 2, which is equal to 6. Another property is that the limit of a constant c times a function as x approaches a number a would be equal to the constant times the limit of the function as x approaches a. For example, let's look at the limit of 5x squared. This property is saying that that would be equal to 5 times the limit of x squared. And we know that the limit of x squared is what? We know that the limit of x squared is 4 as x approaches 2, leaving us with 20. Now, another property that we'd want to look at is the property of products. So we have the limit of f of x times g of x as x approaches a would be equal to the limit of f of x as x approaches a times the limit of g of x as x approaches a. For example, let's say that we're looking at the limit of x cubed as x approaches 2. Now that would be equal to the limit of x times x squared as x approaches 2. And based on the property of the limit of products that we learned about a while ago, that would imply that we have the limit of x as x approaches 2 times the limit of x squared as x approaches 2. And we know that since we're finding the product of these, then the limit of x as x approaches 2 we know is 2, and the limit of x squared as x approaches 2 is 4, leaving us with 8. Now, another property that we'd want to look at is the quotient property, where we're finding the limit of f of x over g of x as x approaches a. And that will be equal to the limit of f of x as x approaches a all over the limit of g of x as x approaches a. Now, two final properties that we want to look at are that the limit of f of x to the n is equal to the limit of f of x. Let's say x is approaching a, all raised to the n. So for example, if we're finding the limit of x squared as x approaches 2, then that would be equal to the limit of x as x approaches 2 all squared, which would give us, since the limit of x as x approaches 2 is 2, we're going to square that, giving us 4. And similarly, the limit of the square root, or the nth root rather, of f of x as x approaches a would be equal to the nth root of the limit of f of x as x approaches a. So for example, let's say we're looking for the limit of the square root of x squared as x approaches a. This property would be implying that we're looking for the square root of the limit of x squared as x approaches 2, which would be equal to, since the limit of x squared as x approaches 2 is 4, the square root of 4, which should be equal to 2. In summary, here are some of the laws of limits that you can write off for future references.